Hi, welcome to part 2 of our gases pre-response practice. This is Mrs. Dahlberg and you are in AP Chemistry. And so if we look at this question, we have a solution of peroxide and we have 6.951 grams of peroxide and it decomposes to water and oxygen. The oxygen's collected in an inverted graduated tube over water at 23.4 degrees Celsius. We're given the volume, and the atmospheric pressure in the room is 762.6 torr. They even, how nice, give us the vapor pressure of the water. It's 23.4, and the water vapor pressure is 21.6 torr. And so question part 1, or part A, asks us to find the partial pressure in torr of oxygen. And so if we know that the total pressure is the sum of all the partial pressures, and in that tube we have not necessarily the water that's formed, but since it's collected over water, that means that we have a partial pressure from the water. So we have not only the oxygen gas that's produced, but water vapor since it's collected over water. And so when you rearrange for the pressure of the oxygen, you get the pressure of the oxygen equals the total pressure or minus the partial pressure of the water. And so if we want the pressure of the oxygen, that is just our 762.6 torr minus our 21.6 torr, or a total of 741.0 torr. And this was 1 point. The next step, you're asked to calculate the number of moles of oxygen. So now that you have the pressure of the oxygen, you're asked to find the moles. And so with the information that we have, with the the volume and the temperature, we can find the number of moles. And so to do that, we would use Pivnert, ideal gas law, rearrange to solve for moles. And so if we have PV over RT, we get the pressure, which is 741 torr, the volume, which is given in the problem, our volume is 182.4, and that's in milliliters. Now, because of the R value we're going to use, we need to convert that to liters. And so if we convert that to liters, we have 0.1824 liters. And so this is the number we want to use. Our R value, since we're using torr, but now we had a choice. We could convert this to atmospheres and use that value, or we can use the 62.36 liter torr per mole Kelvin. And the last part is the temperature, and we know that if it's 23.4 Celsius, we do need to convert that. And to convert it to Kelvin, we add 273, and so we get 296.0 what is that? A 4.4 Kelvin. And so when we multiply and divide, we get the number of moles, and we get 0.007304 moles, or, and that's really hard to read, 7.3004 times 10 to the minus 3 moles. Okay. So, going back, this was worth 2 points. You had 1 point for the correct substitutions. In other words, using liters instead of milliliters and using the correct R value and changing the temperature to Kelvin, and 1 point for the correct answer. So 2 points for that one. In the next step, you're asked to find the number of, or the mass in grams of the H2O2 that decompose. And so if we look at that, we would take our answer from the previous question, our 7.304 times 10 to the minus 3 moles of H2O2. And, or sorry, not H2O2. This is our moles of just oxygen that we calculated in the previous answer. And now we're going to convert it, since this is the moles of oxygen formed, we are going to use the mole-to-mole ratio in our balanced chemical equation, which is a 2-to-1 ratio. And for every 1 mole of oxygen, we needed 2 moles of H2O2. And we are asked not for moles, but for grams, so we have one more step. For every 1 mole, if we find the molar mass, we find that we have 34 grams of H2O2 in every mole. So using that molar mass and the mole-to-mole ratio, we get 0.497 grams. And this was worth 1 point for this mole-to-mole ratio right here, and 1 point for the correct answer. So the last part says, calculate the percent of H2O2 by mass in the original 6.95 gram aqueous sample. And so any percent is the part over the whole times 100. And so, so if we look at that, the part that we have is our calculated amount. We have found that we have 0.497 grams of the peroxide, and the original sample had a mass of 6.951 grams. And so if we divide those two and multiply by 100, we'll find that there was only 7.15% in our original sample. And there is just 1 point for the final answer in this. Of course, you must show your work to get that point. Okay. And then part E asks about the oxidation numbers of the oxygen atoms in peroxide. And so if we look at the oxygen, there are 2 places we find it, in the peroxide and the oxygen gas itself. And so if we start with this one, oxygen is in a compound is always -2 except when it's in a peroxide. So this is the exception. And so the charge of this one is -1. Any element by itself has an oxidation number of 0. And so those are the two oxidation numbers. These were 1 point each for a total of 2 points. Now this last part says write the balanced oxidation half reaction for this reaction. And so the oxidation half reaction, there's only one reactant, H2O2. And so since there's only one reactant, it is going to both be oxidized and reduced. In the reduction half, we have gaining electrons. And so if we look at this, oh, sorry, we're not doing the reduction half, we're doing the oxidation half. So in the oxidation half, we have this peroxide losing electrons, and it loses electrons. This oxygen goes from a -1 to a 0 charge when it forms the O2. Now, since there's 2 of them, we know that it lost 2 electrons. Okay, and so we have our oxidation compound. Now there's one more step. In this, we have to balance not only our atoms, but our charges. And so there is one more product. We have to account for our hydrogens. And so the hydrogens are found in the water, but in this half, they are H+ ions formed. And if we look at this, we have now balanced all of our atoms. We have 2 hydrogens, 2 oxygens, and we've also balanced our charge. Our overall charge before was 0, and now we have -2 and a +2, which add up to be a net charge of 0. Thank you, and this is the end of this free response. And one more thing, this last part was 1 point. 1 point for the correct reactant and the correct products. And then you also earned another point for balancing. And so that is how the points on this problem are distributed. Thank you and good luck studying your gas laws.